started. So contents, just as we mentioned before, a high look at remote condition monitoring and a quick starter with about Senceive. So Chris, do you want to start it off with about Senceive?
Yeah, definitely. Kind of 3 or 4 key points there. So for those that aren't familiar with Senceive, we were founded in the UK, based out of London, 2005, and actually we were originally a spin-off, and a spin-out from a kind of highly reputable engineering research university, the University College London. We've maintained a headquarters in London, UK since then, and obviously have kind of built on some amazing technology and IP from the outset. Principally, we are in the business of the design and manufacturing of remote condition monitoring solutions, and more specifically and pertinently for Senceive, we specialize in wireless remote condition monitoring solutions. A lot of different hardware and then the kind of supporting software and infrastructure that goes with these sorts of solutions. The journey's been a fantastic one for Senceive. We're started in a lab in London 15 years ago. We're now kind of operating across 40 different countries, at least at the moment, systems deployed in 40 plus, kind of nominally identified by the green dots. And what is nice is that we've now got 3 flagpoles down across the globe. So the pink dots, the kind of looking at obviously the London HQ, and then we've got a R&D office down in Perth, Western Australia, and kind of more recently we set up shop in Dan's backyard in Brooklyn, New York. So yeah, we have a presence and a foothold in North America, and we expect to kind of have more flags cropping up as the business continues to evolve. And then finally, in terms of where we focus and what we spend our time doing, we are pretty much exclusively and razor focused on 3 key markets: civil engineering, infrastructure, and the construction activities around that. Rail, it's very parallel to kind of civil engineering and infrastructure, but rail is a specific discipline we have a lot of activities in. And finally, mining goes hand in hand with civils, and our technology is definitely more than suitable, very applicable to both boards, mines, and open pit mines.
Great, thanks, Chris. So yeah, let's dive right in, starting with what is remote condition monitoring. So first and foremost, it's the physical use of sensors installed on some structure or element, for example, the inside of a tunnel, as shown here. With these sensors, we are transmitting data wirelessly through on-site telemetry and then sent to a remote server via cellular network, Ethernet connection, or even possible via satellite communication. So then to perform continuous measurements of parameters that the specific sensor is capable of. With remote condition monitoring technology and the advancements we've made with efficient power usage, measurements can be taken at high frequencies while still operating for years on small batteries. Shown here in this photo are triaxial tilt sensors installed on concrete ties where they are performing continuous track geometry measurements, while, as you can see, a survey team is on site for baselining that sensor's position. Remote condition monitoring is unmanned and automated, allowing users to understand what is happening in areas that are heavily populated or remote, like the example of this triaxial tilt sensor installed at a reservoir site. So it's important to note that by deploying an unmanned and automated system, you are able to reduce on-site labor, which is both a safety consideration as well as a cost-effective monitoring method. And of course, it is this method to detect change from some baseline or initial position from the time of install. Change detected can be used to adjust, for example, maintenance schedules, adjust construction methods, or to understand more hazardous movements that can pose a risk to people's safety, like this section of rock along a cliff, which is being measured for displacement and tilt. And on to Chris with the why.
Yeah, onto the why. So why do we deploy remote condition monitoring and remote condition monitoring solutions? Well, kind of 4 points to cover here. First one, the protection of assets and investments. Infrastructure is expensive and often, designed to last a long time, but also has many other neighboring forces in play that would require sensors and sensor systems to be required. And kind of on top of that, and to do with protection, if we're talking about particularly new construction, then the big insurance firms that underwrite major infrastructure or civils projects, they typically want to reduce their risk as much as possible. And monitoring and collecting that data and understanding how things are interacting and behaving is a risk reduction method. So we typically find that insurance companies are also very, very powerful in defining and demanding that monitoring, and therefore in many cases automated and remote condition monitoring be used on civil and earth and infrastructure. Second one is kind of reduction of whole life monitoring costs. So specifically, if we're talking about remote and automated condition monitoring, as opposed to say manual or kind of periodic monitoring, in some scenarios where access or scale could demand a lot of resource-heavy activities, therefore perhaps manual monitoring becomes very cost ineffective. The investment, the capex investment in a sort of remote condition monitoring platform solution could actually deliver a reduction in whole life cost of monitoring across that project or that asset life cycle or lifetime. Third and very kind of important point, keeping people safe. Monitoring solutions are in many ways an early warning system and are, quite commonly deployed on sensitive or possibly possible structures of concern that pose a risk to human and kind of civilization safety. So, they are there to help keep people safe. And finally, the measurement of performance or performance measurement. A lot of structures or a lot of construction, there's a lot of design and theory work that's put in place pre-construction that companies, clients, and engineering firms want to, in effect, compare to during the work. So it's design versus kind of build in terms of is the data in line with their initial modeling and expectations. Onto the when.
Right. Onto the when, exactly. So when do we perform remote condition monitoring? So one of the more common situations is during construction-related activity where, for example, the impact of that activity itself could upset the foundational element of a bridge pier, for example, or shown in this photo to measure the performance of the structure that is being built, and in this case, remote convergence monitoring during a mining operation. Is also used when an asset owner has the need to evaluate its structure for potential repair or replacement. So much of the early construction of our national infrastructure here in the US dates back to around the century mark, when much of that infrastructure was designed for expected lifespans of 50 years. So this has forced asset owners to evaluate whether to repair or completely replace certain structures. Remote condition monitoring is used as part of this evaluation process to provide owners with continuous information around the health of a structure, which can tell them, amongst other things, whether it is stable enough to keep in place with potentially minor repair, or if that structure is in critical condition and requires more immediate replacement. So it's also used in areas that are well remote in general by nature. Access difficulties can be due to the nature of where it is located, as shown in this example of a cliff face that would be impossible really to access for physical measurement without some extraordinary budget available to the team. Or for another example, it can simply be in railroad right-of-way, above ground, or in a tunnel where access is both dangerous and disruptive to the railroad's operation. And finally, when a high frequency of readings is simply just required. This can be to understand the more immediate impact of construction on some critical infrastructure while that construction activity is being performed, like, for example, compensation grouting. Or it can be when the remote condition monitoring system is being used as an early warning for catastrophic movement, as shown in this photo where a network of triaxial tilt sensor nodes mounted on stakes embedded into the topsoil of the slope are proactively and remotely monitoring for potential landslide into an active railroad corridor. As I mentioned earlier, I believe in the what is section, the advancements of this technology now allow for these high frequency readings while keeping many years of battery life for minimal maintenance.
Onto the where.
Onto the where.
Yeah. You got me okay? I think I've rejoined the main session now. My computer's decided to play ball. You hear me all right?
Oh, great. Yep.
Excellent.
Hear you great.
Yeah, there we go. I can see the screen as well. Where? Yeah, kind of continuing with the theme. So we kind of got 4 key points around where remote condition monitoring systems could be, should be, and are actively deployed. So the first one is on infrastructure, so either critical infrastructure or nearby infrastructure within a project influence zone. So what we mean by that is typically in new construction projects, the building of a new asset kind of disrupts the equilibrium in the surrounding area, whether that's structural or geotechnical. And part of that, kind of as alluded to earlier, that insurance demand from the underwriters and the protection of neighboring property and infrastructure, monitoring systems are actively deployed on neighboring assets to make sure that they remain safe and structurally stable. Where in terms of physically, we're typically 2 types, both structural, so i.e. on sort of man-made objects, and then geotechnical elements, so either hewed out of the ground or drilled or buried into the ground, looking at the earth, kind of physics and properties as opposed to structural properties, and these can either be temporary works or temporary assets, or indeed the permanent construction assets being put in place or kind of are already there. So both structural and geotechnical, and then either temporary or permanent. You've kind of got a combination of any of those 4 properties really. Third one, engineered structures identified for health assessment. So back to Dan's comment around asset life extension, and the need for monitoring infrastructure that's perhaps past their initial design life, where DOTs or clients decide to replace or add additional infrastructure assets, bridges in this example, next to an existing bridge. They will typically take the opportunity to monitor the existing bridge, keep an eye on its performance and its condition. But we're seeing more and more clients recognize the benefits of those retrofitted systems on the existing infrastructure by installing systems as the new structure is being built, i.e. they get from commissioning a monitoring system that they can then take engineering decisions on from the very start, or the very kind of early stages of a structure, all the way through to any sort of decommissioning we expect in decades or centuries time. And finally, Again, back to that kind of keeping people safe, they're often used in hazardous areas or areas that have been deemed as high risk, whether due to stability issues or construction activities, or just particularly very sensitive areas around on networks. Monitoring systems are used to kind of pick up any early warning signs for major failures. I mean, you'd argue in this case it was probably a bit late, but you know, these sorts of major earthwork failures on rail track embankments and cuttings and any sort of geotechnical assets are very common. Water is and rainfall is actually the railway industry's kind of worst enemy, and you know, there's plenty of rail track around the world in areas where there's a lot of rainfall. So these sorts of failures are common and need to be identified before a high velocity moving train gets anywhere close to these sorts of parts of the track. So very, very common and very typical for high risk and hazardous areas to have automated and remote condition monitoring solutions deployed on them.
All right, and then once the screen loads, sorry, okay. And for the last section, and finally, how do we perform remote condition monitoring? So one of the more exciting parts. So, well, of course, the appropriate solution first needs to be selected. This can be the situation where a project specification has been created and outlines the specific sensor type for each parameter that the owner or engineer wants measured. Sometimes, most of the time, really, in a specification, it's even down to the sensor's own required resolution and reading frequency. Or in some cases, there's an owner who's concerned that their asset is unstable. There's no project specification. This isn't something planned, budgeted for. They really just want to continuously measure that asset to understand its behavior, and even have the desire to receive early warning of sudden movement before or at the time of catastrophe. Probably most similar to the case of what Chris was just showing with the hazardous areas, with the washout below the rail track. So, at this stage, it's always very important to include a monitoring expert into the conversation to ensure that the appropriate solution is being selected, whatever it is, and all limitations and advantages are understood prior to installation. We see all too often that a product is selected based on price, based on relationship, and it may not be the right solution for the application, and this can lead to a lot of frustration down the line, not only with the entity performing monitoring, but to the owner who paid for monitoring to be performed. So once that process is complete, everyone's happy, POs are issued, and equipment's received and tested, it's on to the installation. So since there are so many different remote monitoring solutions on the market, and even more application of these solutions, there will be varying degrees of installation experience and expertise available. So, proper vetting is very important. It's an integral part of this process, not just selecting the right solution, but in combination, also the outfit that is performing the installation. So once the installation is complete, then it's on to what I and others call the commissioning process. So this is where we confirm that all data is being received by the hosting software, and then where that software is set up to properly display and provide data that is in a format that both makes sense and is useful to the monitoring team and the person paying for this data. It is also importantly where data is transformed into engineering units and parameters are set with threshold values if notification of exceedances are required. So, there are varying types of different softwares. There's control softwares which set up and control remote monitoring solutions, and there's also data visualization and management software, which is, normally a nice client-facing software that provides a lot of extra value and insight into that data, what it means on site. So once this process is complete, then it's sitting with the monitoring team with all involved parties and agreeing on the big if, then, what scenarios. So if, for example, this movement is detected, then what do we do? Does construction stop? Do we stop train traffic in a certain area? Do we adjust construction methods? All very important considerations depending on the application, because data is only as useful as you make it, and action plans are how you decide what to do with it.
Yeah. So on your on your if, what, when, Dan, if it's St. Patrick's Day, what should you do? You should drink a Guinness, and when?
That's right.
As soon as possible.
That's right. So thanks for listening, everyone. Any questions? We're going to go here and pull open the questions section.
Yeah, I'm also going to prove that I wasn't a bot or a pre-recording and managed to jump on here at the end. So have we got any questions yet?
I'll join your lead.
Ladies and gents, any questions from kind of that pretty high level and quick overview of how Dan and I see the world of remote condition monitoring? If you can kind of submit them via that questions tab, and we're here for the next kind of 15-20 minutes to answer those. But we've either done a very good job, Dan, or a very bad job, because there's no questions.
All right, well, here comes one. I've got one here. So what products do you provide for remote condition monitoring? So we're the manufacturer of some of the products that you saw in those slides. It is the data acquisition, so it's the gateways. It is some of our core products, which are embedded sensor nodes. So they're sensors that also have the telemetry embedded in them around the triaxial movement, optical display sensors. We also have our latest product being the FlexiMeasure IPI solution for boreholes, for structural applications. But happy to take this offline and talk more about that. Thank you.
There's another one that's come in, Dan. Has Senceive deployed their systems and sensors on all of the different scenarios that you've kind of talked through today? So yeah, I mean, obviously a lot of those images were from our customers using our sensors on some of their on their projects. The variety of case studies and projects that we've managed to kind of work with our partners on has been brilliant, and it's very diverse, both globally, geographically, and application wise. But yeah, kind of all types of construction, whether that's tunnels, bridges, dams, highway, rail. We've got a lot of experience working with partners in that space. And then mining, we've kind of done both bored, or we've supported both bored and open pit mining across the world, tailings dams to more particularly around mining, and then general asset life extension. So kind of famous buildings and kind of long-lasting infrastructure that are national landmarks. We've been asked to kind of provide sensors for those projects as well. Next one, Dan, is your hardware tied to a specific online data analysis and presentation system? Do you want to take that?
Is your hardware tied to a specific online data analysis and presentation system? So yeah, I'll take that one. So right, so by default, our gateway devices, which act as the base stations, the central point of data acquisition for all the nodes on the platform, which are connected to either external sensors or they are the measuring sensor themselves, all route by default, yes, to our web monitor software, which is cloud hosted. So at that point, some clients prefer to use that software for data visualization and basic reporting. but it's also API enabled, as well as the ability to automatically export data to a third-party data management software. So, it depends on the project, depends on the client. Everyone has their own preference for that.
A few more questions coming in now. Can we use FlexiMeasure for track settlement monitoring? Do you want me to take that? Yeah,
sure.
Okay. FlexiMeasure, we're trialing it, or we've got some test sites on track settlement, so track bed monitoring. Track bed's obviously a much harsher environment than near track, so we want to kind of be sure that our system kind of stands up to those tests before we kind of give it the green light, but we are kind of looking at that as an application at the moment. Near track monitoring, so structures around the track that would be settling, FlexiMeasure is absolutely kind of fit for purpose for those types of structures.
Great.
Next one.
Okay, got another one. Yeah, I can take this one. How do you integrate the results from your sensors with classical surveying using total stations? So I imagine this question is probably prompted by maybe some of the images showing the track application with the tilt sensors, as well as the prisms there with total stations, or I think it may have even shown in AMTS. So right, first comment on that, there are situations where AMTS or classical surveying is more beneficial. And there are benefits to sometimes having sensor technology, only. And then there's also situations where it's nice to have them installed together for a, complementary and redundant monitoring system. So, it's always good to, like I said, engage with a monitoring expert to determine, what is the appropriate solution for the application. But to directly comment on the question, how do you integrate the results? I think it's there are two complementary ways of taking measurements. A classical survey is going to give you, geospatial position or change in position geospatially. A tilt sensor, for example, is going to give you a rotation at a single point. But if that sensor is installed on a beam or a series of beams, then you can calculate, differential movement, settlement profiles, etc. And, using those two together, you can correlate the two to, really provide more information around, what is actually happening on site. So I hope I addressed that clearly. Happy to talk about it more. It's really hard to address, more generally, because it's really per application, per sensor. There's tilt sensors, there's, inclinometers for inclination, beam chains, etc. But they are two complementary ways of performing measurements.
Next one, can you tell us more about how the sensors communicate with each other in the wider world? How are the cameras integrated? So obviously looked at seen the camera on the early slides, and what makes them take a picture? So I mean, probably bounce around this one, Dan, between us, but because there's a whole swathe of information we could deliver here. But we have two platforms at Senceive. We have a mesh topography and a kind of star LoRa point-to-point topography. The mesh is actually proprietary kind of technology and platform to Senceive. It's called Flat Mesh, and what it allows us to do is it operates within kind of the 2.5 gig bandwidth, so i.e. kind of Wi-Fi bandwidth, but it's our own system, and that gives us kind of a lot of power and a lot of capabilities across the mesh network between nodes and gateways. So the nodes all speak to each other. Think of it a bit like a spider's web. Everything's connected. And to answer the camera question, so one of the neat things we've done at Senceive with these solutions is we've kind of created a bit of an intelligent monitoring system. So because the nodes have got network intelligence in their mesh network, when we plug a camera into that network, theoretical plug, we can basically tell the system that to run its own sort of intelligence locally, so not being dictated to or controlled kind of via PC or monitoring team sort of back in the office. If a node detects some movement, so it kind of sits in a steady standby state, if it picks movement outside of its kind of defined monitoring frequency, it will wake up, take a reading, and then it will tell its neighboring nodes to also take a reading, because that's kind of teaching itself that, hey, there could be something going on here. At the same time, it tells the camera to wake up and take an image just as a sense check. Now that kind of functionality is kind of self-learning. So if there's more readings are detected, or possible readings, the nodes then keep that, they increase their frequency, they'll communicate to wider nodes to take more readings, and all of a sudden you've got this kind of dynamic system that's telling itself to take readings because they're seeing movement, and take images that can then be kind of analyzed back in the office, that are kind of time stamped to those kind of alerts, and that kind of intelligence there is actually only capable on the kind of the mesh platform, and using that kind of powerful bandwidth. And it's a very kind of unique Senceive product, and it's proving kind of very popular in remote condition applications, particularly on sort of large earthworks or structures that are, people are not going to be able to get to for a long time, but rail or highways are kind of cutting through them. So that's kind of a bit of a snippet into that. We could spend an entire hour talking about that kind of technology, but that's for another rainy day.
Yeah, exactly. That's a good summary. It's using the flat mesh system. It's more of a proactive way of monitoring, really, than a reactive way of monitoring.
Yeah. Next question, Dan. Have you guys deployed sensors to monitor crack displacement? Same follow-up question. Typically monitored using crack gauges.
Yeah, definitely. That's definitely a technology that's existed for some years now. Senceive specifically, we do. It's actually one of our external sensor interface nodes. So these nodes operate on our wireless platforms and can be connected to correct external sensors that can replace typical crack gauges, the plastic avant-garde crack gauges, for that remote and continuous monitoring. Those sensors sometimes, they can be potentiometers, they can be vibrating wire crack gauges. Our technology interfaces with a lot of the manufacturers on the market in the US, abroad.
Yeah, and then we've had a question about kind of getting Senceive product, where they can get it from. So we have a kind of a strong channel in North America. We've got a number of kind of distribution partners that are geographically kind of well situated around North America, and then we've also got a couple of kind of monitoring, what we'd call monitoring empowered partners, kind of service experts that will do more and can do a lot more in terms of integrating a lot of different sensor technologies, a lot of different techniques, and actually kind of installation, management, and monitoring of those systems. So we have kind of two different types of channel in North America, kind of distribution that have the big customer support and a place for kind of purchase, and then kind of the more service delivery experts on a monitoring contractor, engineering firm type front.
Right. So yeah, we always like to make the message clear that we are not a monitoring company. We are the manufacturer of this technology, who does provide a very high level of support from the point of engagement, evaluating the correct solution for the correct application, but then post sale, either for our network or for the end user, if our partners and dealers do decide that's the way that they want to go.
I think certainly that's all of the questions that have come in answered. 5 minutes ahead of schedule as well, so I'd say that's a job well done.
Yep, looks good. I don't see anything else.
No, I don't see anything else. So I think
all right,
maybe we draw breath there and call that a day.
Very good.
Yeah, everyone hopefully is rushing out to get a pint of Guinness, or at least a can or a bottle from somewhere, and putting it into a pint glass.
Well, it's about time for you. I've still got a few more hours to go.
Well, they do say it's a meal in a glass, so one could justify it as a late lunch. But yeah,
very good.
Kind of just a thanks from me to all those that have joined. Hopefully, found it insightful and educational, and maybe a few nuggets of information in there you can take away with you. Any follow-up questions, or comments, our emails are at the bottom of the screen. So yeah, kind of from me, thank you very much, and hopefully we speak to you all in the near future.
Absolutely. Take care, everyone. Stay safe.
Thanks all.